A warm greetings to you all. Welcome back to Physics Online class. I hope you are all safe and good in your home by the grace of God. And so far we have learned some topics from the first lesson. Have you remember what's the lesson? Yes, laws of motion. So in this chapter, already you learned certain topics. So today first we are going to recall that. After that, today portion we can learn. Okay. First we learned about inertia. What do you mean by inertia? Ability of a body to maintain its state of rest or motion is called inertia. It means that a body will continue in the state of rest or in the state of motion until an external unbalanced force acts on it. That is inertia. Now you are going to see a small video clip to understand better about Newton's first law of motion and inertia and the types of inertia with example. Okay, have you all ready to listen the video clip? Let's go.
In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked on the ground would keep moving forever or after some time would naturally stop moving? The ball will continue to move unless an object of force stops it. Here comes Newton's first law, which states a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. To understand Newton's first law, you need to understand what unbalanced force is. If you have seen a game of tug of war, you would have seen two teams pulling a rope in opposite directions. If the rope doesn't move, the forces applied by the teams are balanced forces as they are of equal magnitude in opposite direction. If one of the team applies greater force, it pulls the other team and the rope towards their side. In this case, the forces are unbalanced as the two forces are of unequal magnitudes in the opposite directions. If one of the team lets go of the rope, the opposite team falls backwards. This tendency to fall backwards despite letting go of the rope is due to inertia. That is, if an object is at rest, it tends to remain at rest, and if it is in motion, it tends to stay in motion. This property of an object is called its inertia. Inertia can be classified into three categories: inertia of rest, inertia of direction, inertia of motion. Certain experiences that we have while traveling in a bus can be explained on the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is the tendency of a body to resist any change in its state of rest. What happens when a fast-moving bus negotiates a right-hand curve on the road? The passengers will tilt to the left. Inertia of direction is the tendency of a body to oppose any change in the direction of its motion. With the application of sharp brakes, the bus stops all of a sudden and the passengers tend to fall forward. This is due to inertia of motion experienced by the upper part of the body. When the bus is moving, the whole body of the passenger is in a state of motion. A sudden halt caused by the lower part of the passenger's body that is in contact with the bus comes to rest. However, the upper portion of the body remains in the state of motion due to the inertia of motion, causing the passenger to fall forward when the bus stops suddenly. Inertia of motion is a tendency of a body to resist a change in its state of uniform motion. Thus, Newton's first law is also called the law of inertia. Well, now this law should make sense. Do you understand why a ball on the ground after being kicked does not keep moving forever? The ball stops after some time due to the unbalanced external force applied by the ground in the opposite direction. Things to remember. Newton's first law of motion states that a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. Two unequal, oppositely exerted forces are called unbalanced forces. Newton's first law is also known as the law of inertia. The tendency of an object to continue its state of rest or of uniform motion in a straight line is called inertia. The three types of inertia are inertia of rest, inertia of motion, and inertia of direction.
I hope you are all understood well, and also you learned the types of forces, is it? What are the two types of forces? Like parallel forces and unlike parallel forces. Did you learn? Then you learned resultant force, isn't it? Okay, and today we are going to learn the next type of force, that is rotating effect of force. Okay, what's that? Rotating effect of a force. To understand the rotating effect of a force, just observe this picture here. The handle of a door. Which place it is there? Yes, it is placed at the edge of a door. Why it is placed at the center or at nearer to the hinges of a door? If it is placed nearer to the hinges, it is difficult to push or pull. But if the handle is at the edge of a door, it will be easy to open or close. Okay. So this effect, that is opening or closing the door, this is also the rotating effect of force. The door can be easily opened or closed when you apply the force at a point far away from the fixed edge. In this case, the effect of the force you apply is turn the door about the fixed edge. So this turning effect of the applied force is more when the distance between the fixed edge and the point of application of the force is more. Okay. So when we are applying the force to the handle of the door, so it can be easy to rotate, okay, or open or close. So, but this handle is at the center position or nearer to the hinges means it is very difficult to close or open. Okay, we have to apply a more force. Okay, so here from the fixed edge to the distance of this force we are applying, the distance will be increases means we have to apply a very less force. Okay, so this turning effect of the applied force is more when the distance between the fixed edge and the point of application of the force is more. So here the axis of the fixed edge about which the door is rotated is called the axis of rotation. Okay, the axis of the fixed edge about which the door is rotated is called axis of rotation. Now we can learn the definition of axis of rotation. The axis of the fixed edge about which the door is rotated is called axis of rotation. What is the fixed edge in the door? The hinges. Okay, about the hinges the door is rotated or the door is open or closed. Okay, this turning effect is called the axis of rotation. Next one is point of rotation. Okay, just observe this picture here. Fix one end of the rod to the floor and apply a force at the other end tangentially. The rod will turn about the fixed point, that is called point of rotation. Here the center point is called as the pivot, that is the point of rotation. So in this spanner we are applying the force in the other end of the point of rotation. The distance between the point of rotation and the force applied is increases, means we have to apply a less force. Okay, so this is the reason the spanner handle is long. Okay, if the handle of the spanner is too long, it is very easy to apply a force. Okay, the turning effect of the force is very easy. Okay, and if the handle of the spanner it is too small, we have to apply a large force to rotate a screw. Just observe this picture here. What is point of rotation? Here one end of this rod it is fixed to the wall. Okay, we are applying the force to the other end tangentially. So the rod will be turned about the fixed point is called point of rotation. Okay, once again we can see the definition of point of rotation. The rod will be turned about the fixed point is called point of rotation. Next we are going to learn the important definition, moment of force. Students, we already learned about what is axis of rotation and what is point of rotation. Okay, based on this only we are going to define this moment of the force. The rotating or turning effect of a force about a fixed point or fixed axis is called moment of the force. Okay, how to define? Moment of force, it is nothing but the turning effect or rotating effect. Okay, about what? The fixed point or the fixed axis. Example, the door fixed in the hinges. Okay, so along the hinges it is what we can say, that is the axis. Okay, the door is fixed with the axis. Okay, so the door is rotated about the hinges. Okay, that is fixed axis. Okay, so the rotating or turning effect of a force about a fixed axis or fixed point is called moment of force. Moment of the force can also be represented by torque. Okay, it can be represented by the symbol is tau. Okay, it's a Greek symbol, so we have to represent the symbol tau, and it is measured by the product of the force and the perpendicular distance. Okay, so in this handle, if you are applying the force, okay, how much amount of force we are applying from the force to the point of application of the force to the axis. Okay, fixed axis or fixed point. Okay, in between the distance is represented d. Okay, so moment of the force we can calculate by the product of force into distance. Okay, so torque tau is equal to F into D. So already you learned the two definition. What is rotating effect of a force, isn't it? So in that you learned what is axis of rotation and what is point of rotation. Along with that you have to learn this moment of force. Okay, what is moment of force and give its unit. Mark this question. The rotating or turning effect of a force about a fixed point or fixed axis is called moment of the force about that point or torque. It can be represented by the symbol tau. So tau is equal to force into distance. Okay. Here tell me what is the unit of this force. Newton, isn't it? Very good. Next, what is the unit of the distance? Everybody knows, isn't it? Meter. So, the unit of this moment of the force is Newton meter. Okay, next question. This moment of force or torque is a scalar or vector quantity? Yes, it is a vector quantity. Okay, because force is a vector quantity. So, this torque or moment of force also is a vector quantity. Next, we are going to learn what do you mean by couple. Okay, in physics, how to define couple. Look here, two equal and unlike parallel forces applied simultaneously at the two distinct points. It constitutes a couple. Here the line of action of the two forces does not coincide. Okay, it does not produce any translatory motion. It will produce only the rotatory motion. Okay, but a couple results in causes the rotation of a body. So the rotating effect of a couple is known as moment of couple. Here you can see the two forces. Okay, the two forces are acting in the opposite direction. Okay, and between the two forces the distance is d. And these two forces will not be coincide to each other. Coincide means that lines of action, one is acting in the downward direction, another is acting in the upward direction. So these two lines of action, it never be coincide. Coincide means what? It never be meet each other. Okay, so it will constitute a couple in mechanics. Okay, now you can mark the definition of couple. Okay, two equal and unlike parallel forces applied simultaneously. Simultaneously means at the same time. Okay, at two distinct point. Okay, so in between the two forces there is a distance is there. So it will constitute a couple. The line of action of the two forces does not coincide. It does not produce any translatory motion. So this couple, it will not move in a translatory direction. Okay, and y means the resultant is 0. The two forces acting in the opposite direction, so the resultant force is 0. Two equal and opposite force. So resultant force is 0. So coupled results causes what motion? Rotatory motion. The rotating effect of a couple is known as moment of a couple. What's the examples of the couple? Okay, example, turning a tap, winding or unwinding a screw, spinning of a top, etc. These are the examples of a moment of couple. So what's the examples of moment of couple? Turning a tap, winding or unwinding a screw. This is also example of moment of couple. Last one, spinning a top. Okay, these are the examples of moment of couple. And now we are going to learn the formula for the moment of couple. Moment of the couple is measured by the product of any one of the forces and the perpendicular distance between the line of action of the two forces. So here two forces are there, isn't it? So one force is acting in the upward direction, another force is acting in the downward direction. These two forces are equal in magnitude. Equal in magnitude, for example, for upward direction the force is 5 Newton, downward direction the same force 5 Newton is acting. So both also acting in the opposite direction, so it constitutes a couple. Okay, so here how to measure this moment of the couple means one of the forces, two forces are there, no? So here we have to take one of the force and the distance. Okay, distance between the two forces here consider as S. Okay, so moment of the couple can be represented the letter M. M is equal to force into distance. Distance can be represented S. So M is equal to F into S. And the unit of this moment of the couple is Newton meter. Okay, in SI system it is Newton meter, but in the CGS system it is represented dyne centimeter. Okay, and by the convention the direction of the moment of the force or couple is taken as positive. Okay, the sign convention, if the direction of the moment of the force is taken as positive, if the body is rotated in the anti-clockwise direction. You all know that, isn't it? Two direction, anti-clockwise direction will say clockwise direction. Okay, so when this couple is rotating in the anti-clockwise direction, the sign will be represented positive, and if it is negative, the rotation is in the clockwise direction. Okay, so suppose the wheel is rotating in the clockwise direction, the sign is taken as negative. If it is rotating in the anti-clockwise direction, then its sign is taken as positive. Okay, this is important for one word question. Okay, next we are going to learn some of the application of torque or some of the application of moment of force. First one is gears. A gear is a circular wheel with the teeth around its rim. Okay, around that wheel, what structure is there? Teeth like structure it is there. And it helps to change the speed of rotation of a wheel. How it will change the speed of rotation of a wheel? Yes, by changing the torque or changing the moment of force. Moment of force is nothing but turning effect of the force. Okay, so by changing the torque, it can able to change the speed of rotation of a wheel. Okay, so different types of gears it is there, isn't it? First gear, second gear, third gear, fourth gear, fifth gear. Okay, usually 5 gears are there in the cars. Okay, students, you have to mark in your book. Okay, application of torque. First application, gears. Okay, a gear is a circular wheel with teeth around its rim. It helps to change the speed of rotation of a wheel by changing the torque, and it helps to transmit the power. Next application of torque is seesaw. Okay, most of you have played on the seesaw, isn't it? There's the difference in the weight of the person sitting on it. What will happen? The heavier person lifts the lighter person. When the heavier person come closer to the pivot point means the center point, the distance of the lines of action of the force will be decreases. So it causes the less amount of torque to act on it. So it will helps the lighter person to lift the heavier person. See here. So on the seesaw, if the two persons are sitting on the seesaw, isn't it? So here one person is heavier, another person lighter person, means what will happen? The heavier person only can able to lift the lighter person, isn't it? But when it will be get balanced, means the heavier persons needs to comes to near to the pivot point. Okay, so that time the distance of the line of action of the force will be decreases. So less amount of torque will be acting on it. So this enables the lighter person can able to lift the heavier person. The next application of the torque is steering wheel. What is the use of this wheel? Do you know? Yes, it is used to transfer a torque or moment of the force to the wheels with less effort. Okay, a very less force is applied to a steering wheel. It helps a large amount of energy will be transferred to the wheel, or large amount of force or torque it will be transferred to the wheels of the vehicles. Okay, so a small steering wheel enables you to maneuver a car easily by transferring a torque to the wheels with less effort. So these are the application of torque. Okay, what are the application? Gears, seesaw and steering wheel. Here just to see the word maneuver, it means that it can able to helps to move the car smoothly. Okay, it's a time to do your worksheet. Okay, first one word questions. The moment of the force is called dash. Second question, torque tau is equal to dash into dash. And the third one, the SI unit of moment of the force is dash. The fourth one, two equal and unlike parallel forces applied simultaneously at two distinct points constitute dash. Next question number 5, rotating effect of a couple is known as dash. Question number 6, if the body is rotated in anti-clockwise direction, the moment of the force is dash. Dash helps to change the speed of rotation of a wheel. The last one, dash enables to transferring a torque to the wheels with less effort. Two more questions. First one, what do you mean by axis of rotation? Define moment of force, give its unit. Third one, define couple, give some examples. Last question, write the application of torque. Okay, these are the homeworks for you. Read page number 4 and 5 thoroughly. Okay, and then you can find all the answers. Okay, thank you students.